Hello everyone, today we're going to be talking about the types of chemical reactions. So far we figured out how to balance these reactions, but now we're going to be able to tell the actual type. And the reason that we want to do that is because it makes it a lot easier to predict what's going to be made as a product. There are 5 general types of reactions. The first one is combination. The second one is decomposition, and these are the 2 that we are going to focus on in this podcast. The third one is single replacement, and the fourth one is double replacement, and the last one is personally my favorite, is combustion, and this is the one that has to do with fire. But we won't get to deal with this one just yet. We're going to just talk about combination and decomposition first. So the first type of reaction is our combination reaction. Another word that can be used is the word synthesis, and the reason for that is synthesis means to make. And you'll see in these combination reactions, we're going to be taking 2 or more substances to make one new substance. So if you wanted to look at a general format whenever you are trying to figure out what type of a reaction we're looking at, you would have your first element plus your second element. Now A and B in this example could be any symbol from your periodic table, and it's going to make something that is going to combine the both of them. So you see how you're taking 2 reactants, remember these are our reactants, and you are combining them to make one product. So let's see an actual example of this. So here we have magnesium, which is going to be the silver portion here in the background, and you're going to combine it with oxygen, and oxygen is that stuff, just in the air. And so whenever you combine those 2, they end up reacting together, and you get this very interesting looking straight kind of flimsy product, and that is actually called magnesium oxide. So you've taken 2 reactants, first one being magnesium, which is that ribbon, the second one being oxygen, which is in the air, and you've combined them in such a way to make the 2 come together and create a new product called magnesium oxide. And that product, there's only one of them, so that is the definition of our combination or our synthesis reaction. Here's all the information that we just talked about in Word format in case you wanted to go through that once again in your PowerPoint. Next, you have your decomposition reactions. Now these guys are going to be opposite of the combination reaction. So in this reaction, we are going to take one reactant and break it apart into 2 or more products. So if you wanted a generalized format of what these types of reactions look like, it's going to be the exact opposite of what we just did before. So we're going to take one reactant and we're going to break it apart into its 2 components. So for this example, we take AB and split it apart so that you get 2 things, A plus B. So you see how these are exact opposites of that combination reactions. So here's our combination reaction just as a reminder, and this looks exactly opposite. It's a mirror image of one another. So again, you have our one reactant and our 2 or more products. So when you're looking at something like this, you would have an example like shown down here. We have mercury oxide, which is this, it looks like it's represented with dark red circles. That would be your magnesium, and your oxygens are these little gray ones. And when it is heated, so if we've ever seen like heat like from the Bunsen burner, that's going to cause it to break apart to 2 separate things, and it is shown in the glassware here as the magnesium being on the bottom, and you can see the oxygen has left some residue on the side of this tubing. That's because oxygen ends up being a gas, So you may not actually see that product, but you can see maybe bubbles that occur or some vapors that happen to be formed. In this example, you start to see the oxygen being formed right in this area. So in this decomposition reaction, again, we're only taking the one reactant and creating two or more products. And a lot of times these decomposition reactions are going to require energy. And the most common type of energy that we know of is heat. So we would often put this over some type of flame. Now the flame isn't actually used in the reaction, just the heat itself. Sometimes you can get light or even electricity. So the most common one that we will see is the one of heat, and that's the one that we would use in lab. So let's give this a shot. So in this example, it's asking you to balance the equation for each of the following. The biggest deal is to figure out, okay, which one is which. So it already tells you, thankfully, in this first example, that this one is a combination reaction. It tells you that it has the two reactants, so we're trying to make one product. And so if we're trying to make one product, we're probably just going to squish them together. But I will tell you that the answer should be copper 1 sulfide. So since that's the case, we need to make sure that we use our ionic rules. And if you need to go back and check those out, please do, because they're going to be very important to completing this section. Okay, so if we have copper 1 sulfide, you would do the cross drop down method. That is our example. Cross drop down is the best way to do ionic equations. And so we would take the two ions, so copper, this guy tells me he has a charge of 1, and sulfide, which is 2 minus. So our overall answer, if you were to do the cross drop down method, would be your Cu. Subscript is 2 because that's what we brought down from sulfur. And then our sulfur, and we pulled down that 1, but remember, we don't write 1s. So our final answer is copper 2 sulfide. Copper with that subscript 2 and then that sulfur. Now in a decomposition reaction, we're looking to break apart our water. So we want to break him apart. And the two things that make up water are hydrogen and oxygen. So hydrogen and oxygen. And if you think back, there are some diatomic elements that I had you remember. Diatomic. And our diatomic elements are as follows. We've got hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Make sure that you write those down, because anytime that you see them by themselves in an equation, they should have that subscript 2. And it looks like both of these answers has that as well. And if you think about the state, we can go even one step further. Hydrogen and oxygen are both gases. So we just learned that you can use those little tiny subscript letters to tell the reader that both of those products are going to be gases. Now that we have the products made, we have all of our products made, we have to balance it. Okay, so think back to the last section. You want to think about how many of each one is required. So if we have 2 hydrogens on the left side for our decomposition reaction, we have 2 on the right. All right, that's great. But if you look over here, our oxygen only has 1. So we're going to have to increase the number of oxygens, but remember, it also increases the whole molecule. So we would have 2 oxygens, but 4 hydrogens. So now we have to fix the right side, or our product side of our equation. We have the correct number of oxygens, but we need to increase that number of hydrogens using a coefficient with the number of 2. So remember, if you were to multiply 2 by the subscript of 2 on our hydrogen, we now have the total number and the correct number of hydrogens and oxygens on both sides. We have to do the same thing for our previous one, so let's clean this up just a little bit to make it easier for you guys to see. All right, so here's our product. We have Cu2S. So automatically we see, all right, we have the right number of sulfurs on both sides. However, we have 2 coppers, so we just have to do a real quick fix by putting the coefficient of 2 on the left side. And those are our final answers. So we have 2 coppers plus 1 sulfur, giving us our copper with the subscript 2, sulfur. And down here at the bottom, we have 2 water molecules being broken apart to make 2 hydrogen gases and 1 oxygen gas. And this again is taken in a little bit easier or a little bit cleaner method. If you want to look through, it's also written in your notes just so that you can remember. But if you work out, make sure that you are applying the rules for balancing these equations. A lot of times, remember, we like to make that chart for our reactants and our products to make sure that we have the correct number of each element on each side, because we must remain constant in order to have to obey the law of conservation of matter. And so that can also be used to check your answer on a test or quiz. The same can be said with our hydrogen, and remember, our water. By balancing it out, we can also use that product reactant or reactant product table and make sure that you use all of the elements. Otherwise, you're going to have an unbalanced equation. All right, that's it for me this time. See you next time.